Alrighty, here we go. If you hear any other stray sounds, well, guess what? It's because I'm doing this as I'm having to watch a swim meet and work at swim meet. So there you go. Alright, review. We're doing the review. For the first four problems, these are talking about, say, how do we understand exponential functions? We want to look at this a times b raised to the x power plus d. Remember that the b is the number next to the exponent. It represents growth or decay. If the number is bigger than 1, it is a growth. If it's between 0 and 1, it's a decay. Your y-intercept is usually 1. Your asymptote is usually 0. Y greater than 0. Whoa, wait, y greater than should be equal to. Nobody corrected me on that earlier today or on Friday. Shame on y'all. Anyways, so y is equal to 0. When we get to the range, it will be greater than 0. Okay, but remember, these two are normally our normal. Y-intercept and our asymptote. So let's look at some of the problems. What do I mean? Oops, too much. Let's see. Let's back it out a bit. So we have 4 to the x power. Because of the number 4, that means it is a growth. The y-intercept is going to go through 1 and the asymptote is going to get close to 0. So the y-intercept is our standard y-intercept. Asymptote is also standard y equal to 0. Domain is going to be all real numbers and the range will be y greater than 0. Keep in mind that the asymptote and the range are the same. So what you should be noticing here, and what I'm trying to make sure you see in the drawing, is that if we put it like right there, this graph is growing. So it's going to go like this and go up and get closer to 0 and goes through that 1. This is a boundary. The asymptote is a boundary. Yes, somebody is whistling loud. I probably should close the door. But we'll get going. Next problem. Oh, I've got to stop doing that. Okay, so this one is f of x is equal to 2x plus 1. This would be, because of the 2, it is a growth. Okay, what does that mean? That means that you can tell that this is going to go up. All right? So that should help you in picking the problems that you need. So that means, okay, now keep in mind though, our y-intercept is normally 1 and our asymptote is normally 0. Well, I'm going to add 1 because I see this plus 1 at the end. So I'm going to say 1 plus 1 and that equals 2. So my y-intercept is 2. My asymptote is normally 0. I'm going to say 0 plus 1, which would be 1. Because 0 plus 1 is 1. So I'm adding that. That would give me, say, an asymptote of y-intercept of 2 and an asymptote of 1. There's my asymptote. So I'm imagining this line is going to make a boundary that the graph will not pass. Domain will still be all real numbers, and the range will match the asymptote, so y will be greater than 1. To the 1/3 x power. Well, that is a decay. Why is that a decay? Well, that's a decay because that is going to be less than or between 0 and 1. There you go. So, you've got this between 0 and 1. That means, but there's no numbers after. There's no numbers in front. So that means that the y-intercept will still be 1. The asymptote will still be 0. Y equals 0. Domain is still all real numbers, and the range will be greater than 0. Look at that. It's a decay. It goes down. That's what that means. There you go. Number 4. We're saying 3 times 1/4 to the x power. Okay, because of the 1/4, this is a decay. Well, what does the 3 do? Well, the 3 takes the normal y-intercept of 1 and the asymptote of 0, and we get to multiply. So the number in front gets to multiply. So I'm going to say 1 times 3 is 3. 0 times 3 is 0. My domain is still all real numbers and my range is going to be greater than 0. Notice here, it goes through 3. It's a decay and it is going close to 0. So there you go. Hopefully that was amusing. I don't know. I was trying to be amusing. Sometimes I fail, but I try. Anyways, let's look at square roots. What do we do about the square roots? Don't even worry about that. I don't even want to know what that was for. Okay, remember, what you want to do is break it down to prime numbers. And then you want to say pairs go on the outside, leftovers stay inside. So 28, hey, 4 and 7, that works for me. 4 becomes 2 and 2. So there I'm saying I'm looking at 2 2s and a 7. So pair of 2s. Okay, so what's the pair? It's a 2. The pair, that goes on the outside. Notice that I'm just putting what the pair was outside. 7 stays left over inside, and there you go. That's your answer. 2 square root of 7. Number 40, or number 11, but 40, 4 and 10. That means 2, 2, 2 and 5. So I got 3 2s and a 5. Got a pair of 2s. Pair of 2s. There we go. That go outside. I got a 2 and a 5 left over. They stay inside. I'll say 2 times 5 is 10. And there you go. Alrighty, next one, number 12. We got a 72, and let's see what I got here. I got a 9 and an 8. Why not? Because, hey, 9 and 8 could work. But could you do 2 and 36? Yes, you could. Could you do 4 and 18? I believe you could. There's different numbers you could charge. 6 and 12? Hey, that works too. Alright, so 9 and 8. 9 is 3 and 3. 8 is 4 and 2. And then I got the 4 become 2 and 2. Now, look here. Those are my end branches. I am focusing on those. So that means I've got 3 2s and 2 3s. And that means I got a pair of 2s and a pair of 3s. Notice pair and pair. And then the 2, this last little 2 is left over. And then there you go. 2 times 3 is 6. So the answer is 6 squared root of 2. Here's another way. You could have done the 72. Gotten 2 and 36, 2 and 18, 2 and 9, and then 3 and 3. Notice that no matter which way you do it, it should break down to the same numbers. Alright, square root of 99 is 9 and 11. That's 9 and 9, which would be, 3 and 3, pair of 3s, you got square root of 11. 50 is 5 and 10, 2 and 5, got a pair of 5s, 5 square root of 2. You could have done also 25 and 2, and you get 5 square root of 2. So you can see here how these things work. At any time you need to pause these, go back, go for it. I'm going through these kind of fast because I don't want to make this kind of too long. Alright, so we got 245. If it ends in a 5, I would try dividing by 5. So 5 is 5 and 49. 49, hopefully you recognize as 7 and 7. And there you go. So I've got 7 square root of 5 because I had a pair of 7s. 243. If it's an odd number, I would divide by 3 or 7. Because those are probably the numbers I'll be using. So 243 divided by 3, hey, it works out. It comes out to 81. 81 you hopefully will recognize as 9 and 9. 9 and 9 is 3 and 3. So there you go. And that means I have 5 3s. So I got a pair of 3s, another pair of 3s. 3 times 3 is 9. And I had a 3 left over. So I had a pair of 3s, 3 times 3 was 9. Alright, now the big one. Numbered 1,440. Oh, that sounds like that would be so hard. But hey, look, it ends in a 0, which means it's divisible by 10. So that's 10 and 144. 144, hopefully you recognize to be 12 and 12. 12 and 12 could be 6 and 2. And then 6 could be 2 and 3. So I got a bunch of 2s, 5 2s, a couple of 3s, and a 5. So I got a pair of 2s, 2 pairs of 2s, a pair of 3s, and I had 2 and a 5 left over. So 2 pairs of 2s gives me 2 times 2, which is 4, 4 times 3, which is 12. 2 times 5, which were the leftovers, gives me 10. And there we go. So keep in mind you need to make sure you have those pairs and take out the pairs. Now, for the last set, the word problems, we want to make sure we use these formulas. Growth, decay, compound interest. You might want to take a second to say pause this, copy them down if you haven't already, because you should have it on your formula sheet, and there you go. Moving on. Number 5. Okay, so 5 says this. 5 is talking about, say, some type of radio contest where there's a $100 gift card and it's going to increase by 2.5% if people don't call in time. So there we go. So what do? We say here, we're increasing by 0.025. That would be there. We started out with $100. Combine the 1 plus the 0.025. There is your general formula right there. Make note, that is the general formula. If I want to find out how many after 10 days, put the 10 in place in the exponent and find your answer, which is $128 and a penny. Number 7, a fully inflated. Let's go to that. That's a minus. This child's raft is losing air. It's losing 6.6%. So we're going to say 6.6%, 0.066, and then make sure you change these always to decimals. They are percents, they get changed to decimals. Subtract, you get 0.934. There's your general equation. And then from there, you could say raised to the 7th power. Press enter. You get 2,790.23 cubic inches of air is left. All right. Don't care what that is. Let's see what's next. Number 6. Number 6 is the compound interest. How do you know it's compound interest? Because it says in the problem compounded. Something about compounded monthly. P represents the beginning. How much did we start off with? $14,000. R represents the percent, which is 6% per year, so that'll change that to 0.06. N is compounds. Compounded monthly means divide by 12. N is 12. Time is T, or years, sorry. So that's 10. We press enter. We get an answer, $25,471.60. Keep in mind that compounds, the ones I'll probably be using, will be 12 for monthly, weekly 52, and quarterly 4. That should change up your answers. Kind of go from there, and let's see what we have. Okay, so now let's look at number 8. Number 8 talks about Miss Acosta received a job as a teacher. Her starting salary was $34,000. According to her contract, she will receive a 1.5% increase in her salary every year. How much will Miss Acosta be earning in 7 years? So, we're now back to saying this is a growth. So we're saying f of x equals 1 plus t. Okay, and again, why? We got a 1.5% increase. Whoopsie. So that would be 0.015, and then she's getting a starting salary of $34,000. I will squeeze that in there. There we go. Per year. Okay, so this is $34,000. 1.015 raised to the t power. That is your general formula. Type that in. What do you get for how many days? Let's see. Okay, so if we do this for 7 years, how much money will Miss Acosta be making? And just true to form for teachers, not much, because now she's making $37,734.70. Oh, happy joy, how much she's getting. That was sarcasm. Anyways, moving on. Have no idea why my phone is ringing. Okay, number 9. In 2015, 2,200 students attended Polaris High School. The enrollment is declining at a rate of 2% annually. What's expected enrollment in 2030? Okay, so what we look at here is that we have, again, a growth. I'm sorry, not a growth, a decay, because we're losing students. Okay, we're losing 2%, so that's 0.02, and they started out with 2,200. Subtract that, you get 2,200.98 T. There is your expected, there's your general formula. Now, they're going to do this from 2015 to 2030, they're expected to lose this, so that would be for 15 years. How many students would be left? Well, that's a good question. I'm glad you asked. Let's find out. Raised to the 15th power, and I get there will not only be 1,624 students, 0.85. If you want to round that off and say 1,625 students, because you can't have 0.85 of a student, no smart alecky remarks about that. There you go. So, again, guys, this hopefully should be fairly easy, but if you do have any questions, feel free to try to send me a little message through, say, Remind, or say through Google Classroom, and I will do my best to make sure I can answer those. All right? Thanks a lot. Good luck.